Welcome learners to our channel. If you are preparing for the Kenya National Examination Council 2025 Integrated Science Exam, this video is your perfect starting point. We have put together a full revision guide covering all the essential topics like the branches of science, acid, bases and indicators, waves, amplitude and wavelength, electrostatics, pressure and its applications, energy, hard and soft water, digestion, dentition and reproductive systems, magnets, rusting, density, simple circuit and laboratory apparatus. We will also explore how substances are separated, all explained in a clear and simple way to help you understand and remember fast. This isn't just a revision, it's a preparation with purpose, so grab your notebook, stay focused and let's walk through every topic with confidence. The first question, which one of the following is not a branch of integrated science? A. Biology, B. Physics, C. Chemistry, and D. Statistics. The correct answer is D. Statistics. Statistics is not a branch of science, it's a branch of mathematics. But biology is a branch of science because it deals with living things. Physics is also a branch of science since it deals with matter and energy, and chemistry is also a branch of science since it studies substances and how they react. So the correct answer in this case, the one which is not a branch of science, is D, which is statistics, which we have just said is a branch of mathematics. The second question, which of the following elements has 4 energy levels? Now in this case, for you to identify the number of energy levels that the element occupies, in this case you need to have what we call electron configuration. And for you to write an electron configuration, then you must know the number of electrons that the atom or the element has. And in this case, for you to know the number of electrons, then we can now get it from the number of protons, and number of protons are the same as number or atomic number. And atomic number is what we have been given here on these elements. Like in the first one, we have atomic number 19, which is potassium, given by a symbol K. In the second one, we have atomic number 13, which is behind the symbol for aluminium. Then in C, we have atomic number 15, which is behind P, which is a symbol for phosphorus. And then the fourth one, we have atomic number 5, which is behind B, which is a symbol for boron. So in this case, the one with 4 energy levels is the first one, A, which is potassium with atomic number 19. It means it has 19 electrons, and these electrons are arranged in 4 energy level, with 2 taking the first energy level, 8 taking the second energy level, another 8 taking the third energy level, and 1 electron taking the fourth energy level. Therefore, in this case, it means this is the first energy level, second energy level, third energy level, and fourth energy level. Therefore, potassium has 4 occupied energy levels. B, which is aluminium, which is atomic number 13, it has only 13 electrons, which are arranged in only 3 energy levels, where 2 electrons take the first energy level, 8 electrons take the second energy level, and 3 electrons take the third energy level. Therefore, in this case, it has only 3 occupied energy levels. Then for C, which is phosphorus, it's atomic number 15. It means it has 15 electrons, and these 15 electrons are arranged in 3 energy levels, where 2 electrons takes the first energy level, 8 electrons takes the second energy level, and 5 electrons take the third energy level. Therefore, it means also phosphorus has only 3 occupied energy levels. And then for D, which is boron, it is atomic number 5. Therefore, it means it has only 5 electrons, and these electrons, only 2 electrons take the first energy level, and then the remaining 3 electrons takes the second energy level. Therefore, it means boron has only 2 occupied energy level. So the correct answer here, an element with 4 occupied energy levels, is potassium, which is atomic number 19, and in this case it's A. The third question, Zakia has 2 solutions labeled A and B. She observed that solution A turned a red litmus paper to blue, while solution B, the red litmus paper, retained its color. What will be the content of solution B? Now in this case, before we look at the possible options that we have been given, let's look at the solutions that we have here on the screen. In this case, we have solution A, this solution A, then we have solution B. In solution A, we have been told the red litmus paper, this red, has turned to blue, like you can see here on the screen. Then for solution B, the red litmus paper, this red, it has remained red. Now let's look at the possible solutions which can be solution A. In solution A, the only solution or the only nature of the solution that can change a red litmus paper to blue is a solution which is basic or a base. But for solution B, we have 2 possible nature of solutions that can make the red litmus paper retain its color. One is an acidic solution. So in solution B, it can be acidic solution because a red litmus paper in acidic solution retain its color, which is red. Another one is a neutral solution. So in this case, we can also have solution B as a neutral solution because in a neutral solution, a red litmus paper retain its color. So in this case, the nature or the content in B is either acidic or a neutral substance. Now let's look at the option that we have been given. A, we have a car battery. This one is acidic, so solution B can be A. B, we have salt solution. This is neutral, so solution B can also be a salt solution. Then C is a baking soda. This is basic. And then D, wood ash solution. This is also basic. So in this case, we have 2 possible answers for solution B. One is a salt solution. Salt solution is neutral and it does not change the color of the red or blue litmus paper. And that's why in this case, the red litmus paper in solution B remained red. Then another possible answer in this case for solution B, where the red litmus paper retained its color, is a car battery liquid. Car batteries are acidic, and since they are acidic, it means the red litmus paper will remain red. Then C is basic, and in this case, it can never be solution B. It could have changed the red litmus paper to blue. Then D is also a basic, and in this case, it could have changed the red litmus paper to blue. But in this case, for solution B, the red remained red. Therefore, in this case, the correct answers are A, that is a car battery liquid, and B, which is a salt solution, which is a neutral substance. Question 4. Cockroaches in a cardboard were killed after an insecticide was sprayed. The insecticide reached the cockroaches by the process of, now in this case, we have a room and then an insecticide is sprayed. Then this insecticide moved from where it was sprayed to where the cockroaches were. Now we have been asked, the insecticide reached the cockroaches by the process of A, osmosis, B, radiation, C, diffusion, and D, absorption. So in this case, the possible answer or the correct answer is a process where particles move from where they are highly concentrated, where they are sprayed, to where they were lowly concentrated. And in this case, the correct answer is C, which is diffusion, which is the movement of particles from a region of high concentration to a region of low concentration. Osmosis cannot be the answer because osmosis is the movement of water molecules from the region of high water concentration to a region of low water concentration. So A cannot be, or osmosis cannot be the answer. Then radiation, This one is a mode of heat transfer where energy moves in form of waves from the sun or from heat. And then for D, it cannot be the answer because absorption is when a substance takes in another, like if you have a sponge soaked in water. Therefore, in this case, the correct answer, where the insecticide moved from where it was sprayed to the cockroaches, is diffusion. That is the movement of particles from a region of high concentration to a region of low concentration. The fifth question, which of the following is the most appropriate first aid action if concentrated acids accidentally spills on a student's hand during a laboratory experiment? A. Cover the hand immediately with a bandage to stop further damage. B. Rinse the hand thoroughly with plenty of running water for several minutes. C. Wipe the acid off quickly using a cloth or a tissue. And D. Apply oil or grease on the affected area to reduce burning. The correct answer in this case is B. That is, rinse the hand thoroughly with plenty of cold running water for several minutes. That is about 10 to 15 minutes. The sixth question, Grado vibrates the end of a horizontal rope and sends a wave along the rope. The wave is as shown in the diagram. So we have a diagram here which shows a wave, and this wave we call it a transverse wave. This is what we call a transverse wave. It's very important for you to know that. And then in this case, the question is asking which row shows the amplitude and the wavelength of the wave. Before we look at the options given, let's first define an amplitude. Amplitude is defined as the maximum displacement of particles from the mean position. So from this wave which we have here, this middle line here is what we call the mean position or the midpoint. And then the wavelength, we also define a wavelength as the distance between two particles. That is the distance between two particles which are in phase. Distance between two particles which are in phase. And in this case, very important for us to define what is a phase. Particles are in phase if they have same maximum displacement. Particles are only in phase if they have same maximum displacement and moving in the same direction. That's what we call particles in phase. And in this case, we have several particles on this wave which are in phase, and I'm going to name them. In this case, we have this particle up here. Let's call it A. And then we have another particle here. Let's call it A2. So those two particles, A and A2, they are in phase. Then another particle that we have is this particle here. If I can call it B1. Then I have another one here. Let me call it B2. Then I have another one here. Let's call it B3. So B1, B2, and B3, these particles are in phase. Then we can also have another particle in phase down here. Let's call it C. This is what we call C1, and this one here, C2. So on this wave, these are the particles which are in phase. A and A2, they are in phase. So in this case, A and A2 are in phase. B1, B2, and B3 are in phase. And also C1 and C2 are in phase. However, A and C are not in phase. B and A and C are not in phase. So A is in phase with A, B is in phase with B, C is in phase with C. Therefore, in this case, for you to know the wavelength, then you have to find the distance between these particles which are in phase. Like in this case, you get the distance between A or A to A2, or you get the distance between B and B1 and B2, this one, that is wavelength, or B2 to B3, this is also another wavelength, or from C1 to C2. And that's why we define a wavelength sometimes as the distance between crests and crests, or troughs and troughs. let's look at the first or the question, which row shows the amplitude and the wavelength. Amplitude, we said, is the maximum displacement of particles from the mean position. If this is the mean position, then this distance from the mean position to the maximum displacement up here is what we call the amplitude, and the amplitude of this wave is 5.0 centimeter. Then the wavelength is the distance between particles in phase, and in this case from B1 to B3 we have a distance of 40, but we have said a wavelength is only from B1 to B2 or from B2 to B3. Since B2 is at the midpoint, therefore the wavelength will be a half of 40. Therefore in this case the wavelength will be 20.0 centimeter. So the correct answer here is the one which has amplitude as 5.0 centimeter and a wavelength of 20.0 centimeter. So the correct answer is B. The seventh question, two identical conducting balls suspended on the nylon thread come to rest with the thread making equal angles with the vertical line as shown on the diagram. So in this case we have this one as our ball, we also have this one as another ball, then they are making an equal angle at this point here, call it theta. And what is important is that we have been told these two balls are conducting balls. It means they can conduct charges. Then the question is, what does this indicate? A, the balls both carry the same type of charges. B, the balls are uncharged. C, the balls are equally and oppositely charged. Then D, one ball is charged while the other one is uncharged. Now for you to answer this one comfortably, then you need to know the basic law of electrostatics, or what we call the basic law of charges, and we're going to define it here. It states that like charges repel while unlike charges attract. So in this case it means if you have a ball here and another ball here, and these two balls, they are likely charged, like in this case they are positively charged like that. In this case, according to the law, they will repel, they will move away. This is what we call repelling. Then if you have this set 1, if you have set 2 where you have this ball and this ball, then we have negative charges in either of the two balls, and in this case this is what we call like charges because they are alike. Therefore in this case they will also repel, they will move away from each other. Then the third scenario that we can have from that basic law of electrostatics is what we call unlike charges, and in this case you will have a ball here and another ball there. Then now you will have the charges inside, these are positively charged, the second one is negatively charged. This is what we call unlike charges, and for unlike charges they will attract, it means they will move close to each other. So this is simply the basic law of electrostatics. Now if we look at the diagram that we have, the balls are not moving close to each other, they are moving away from each other. It's either they are positively charged like that, or if they are not positively charged, then the two of them are negatively charged. The two of them are negatively charged, but the main thing is that they have like charges. So the correct answer in this case is that the two balls have the same type of charge. The 8th question, Maropia is to measure 20 cubic centimeter of sodium hydroxide. What instrument could he use? A, hydrometer, B, measuring tape, C, hygrometer, and D, measuring cylinder. The correct answer in this case is D, that is the measuring cylinder, because a measuring cylinder is used to measure approximate volumes of liquids in a laboratory. It can never be A because hydrometer is used to measure density of liquids. It can never be B because measuring tape is used to measure length, not volumes. And it can never be C because hygrometer is used to measure humidity in air and not the volume of liquids. Question 9. The following devices operates on the principle of pressure in liquids except A, straw, B, water pump, C, flute, D, siphon. A, which is a straw, operates under the principle of pressure in liquids. B, which is a water pump, either a force pump or a lift pump, they operate under the principle of pressure in liquids. C, a flute, this is a musical instrument, does not operate under the principle of pressure in liquids. And D, a siphon, this one operates under the principle of pressure in liquids. So in this case, the correct answer, the one which is not or which does not operate under the principle of pressure in liquids, is a flute, which is a musical instrument. The rest operates under the principle of pressure in liquids. Question 10. Which list of the energy sources contain only of renewable sources? Remember, renewable sources, these are sources of energy which can never be exhausted. Therefore, in this case, let's look at the first option. A, coal, wind, and oil. Coal is non-renewable. Wind is renewable. Oil is non-renewable. So A can never. B, solar is renewable. Wind is renewable. And geothermal is also renewable. So B is right. C, natural gas is non-renewable. Coal is non-renewable. Petroleum is non-renewable. So C can never. Then D, nuclear is non-renewable. Petroleum is non-renewable. And gas is also non-renewable. So the correct answer for a set with only renewable sources of energy is B, which contains solar, wind, and geothermal. These sources can never be exhausted since they are naturally obtained. Question 11. The building block of a material with the smallest unit of matter that retains the properties of an element is A, an ion, B, a molecule, C, an atom, and D, a proton. The correct answer in this case is C, which is an atom, which we define as the smallest particle of an element that cannot be split into any simpler mean by any chemical process, and it retains the chemical properties of an element. A is not the correct answer because an ion is a positively or a negatively charged particle which is formed when an atom loses or gains an electron. B cannot be an answer where it's a molecule. A molecule is defined as a group of atoms of the same or different particles which can exist independently. And D can never be the answer because a proton is a positively charged subatomic particle. Question 12. Why is the reaction a chemical change? So in this case, we have a reaction and it's a chemical change. Now the question is, why is it a chemical change? So in this case, we have magnesium reacting with oxygen to form magnesium oxide. This is a chemical change because the substances which react, that is magnesium and oxygen, the product which is formed, this is what we call a product. The product is completely a new substance. So the reason why this one is a chemical change is because the substance which is formed is new. That is, the correct answer is A, a new substance is formed. Question 13. 5 drops of soap are added to equal volumes of different samples of water. The 4 test tubes are shaken and results obtained as shown. Which test tube contain the softest water? So in this case, we need to know that we have a difference between hard and soft water. Hard and soft water. And hard water is defined as water which contain dissolved minerals of magnesium and calcium ions, while soft water does not contain dissolved minerals of calcium and magnesium ions. Now, this presence of these ions in hard water makes it hard to form lather, also does not form lather easily. But the absence of calcium and magnesium make soft water to lather easily with soap. And then this makes hard water to form what we call scum. Then soft water does not have scum. Therefore, in this case, let's go to the options that we have been given. In the first test tube, that is A, we have some lather. And then in test tube B, we have some lather, and some scum. Therefore, it means this water is not soft. In test tube C, we have most lather, and then in test tube D, we have most scum. Now, the one which contains scum, we have said, is hard water. So this one is not soft, it's hard. And also A is B is also hard. Now A, if you compare test tube A and test tube C, C has most lather than A. Therefore, it means C is the softest water, or it's the softest test tube in this setup. Question 14. The diagram below shows a tooth. 6-year-old Zawadi is missing a teeth like one shown. So in this case, the function of incisor is for biting. Now let's go to the question. Which problem will she experience while eating? A, difficult in biting pieces of food. This one is correct because the teeth that we have here is for biting. B, difficult in chewing. Chewing is for molar and premolars. Then this one is not correct. Difficult in grinding. Grinding is molars and premolars. And then difficult in swallowing. In this case, the correct answer is A, difficulty in biting pieces of food. Question 15. Faith is going to test some different materials to see if they conduct electricity. In this case, this cross with a circle represents a bulb, while these two lines, one long, one short, represents a dry cell in the circuit. Now the question is, which of these circuits should she use? A circuit which she should use to test if a material is a conductor or not. So in this case, let's look at the first option. We have this dry cell here. This is the cell. Then the current will move from this positive terminal of the cell in this conductor. When it comes to this conductor, it will pass through this test material, then to the bulb. Now, if the bulb goes on, then it means this material is a good conductor. So Faith can use the first option. Option B, in this case, we have a dry cell. Now, current will move from the positive terminal through the conductor. When it comes to this junction here, the current will split into two according to the Kirchhoff law. Now, in this case, some current will move to the bulb and some current will move to the test material and then back to the negative terminal. So therefore, in this case, whether this test material passes current or not, the bulb will go on because some current split at this junction and pass through the bulb. So in this case, you cannot use this one. It cannot show you whether this material is a conductor or not, because whether with the test material or without the test material, the bulb will go on. So B cannot be used. Then C, we have a cell. This is a cell. Then current will move from the positive terminal to the test material and then back to the cell. In this case, either the test material is conducting or not, you cannot be able to see because we don't have an indicator. We don't have a bulb which will go on so that we can see whether current has been conducted or not. So this one cannot be used by Faith. Then B, we have a cell, and then this cell current will flow through this conductor, and when it reaches this junction, just like option B, current will flow or will split into two. Some will go to the test material, some will go to the bulb, and then back to the negative terminal of the cell. So in this case, whether this test material is there or not, the bulb will still go on. So the correct answer is A. Question 16. Which plant cell structure merges its function? So in this case, we have a structure and the function. A cell membrane provides strength and energy. This is wrong because a cell membrane is the one which controls the movement of substances in and out of the cell. So in this case, this function is not for the cell membrane. B, chloroplast absorbs light energy. This one is correct. Chloroplast is used to absorb light energy, which is used during photosynthesis. Then C, ribosomes, and the function that we have been given here is to provide protein. This one is wrong because the function of ribosomes is to make protein needed for cell function. So this function is wrong for ribosomes. And then finally, the vacuole. In this case, we have been given a site for chemical reactions. This one is wrong because the function of vacuole is storage and maintaining cell structure. So in this case, the correct answer is B, a chloroplast, which is used to absorb light energy used in photosynthesis. Question 17. What is a function of hydrochloric acid in the stomach? A, to help absorption of all food in the stomach. B, to prevent chemical digestion. C, to kill microorganisms in the ingested food. And D, to prevent the stomach contents being too acidic. Now, what you need to note is that hydrochloric acid in the stomach serves two purposes. The first purpose of hydrochloric acid is to provide acidic medium, which is optimum for enzyme action. Another one is to kill microorganisms. Now let's look at the options given. A, help in absorption of food in the stomach. This is wrong. B, to prevent chemical digestion. This is also wrong. D, to prevent the stomach contents from being too acidic. This is also wrong. Now the correct answer is to kill microorganisms in the ingested food. This is the correct one. So the correct answer is C. Again, we have said it also provides an acidic medium for maximum or for optimum action of the enzymes in the stomach. Now question 18. Which row about the anther and the stigma of a wind-pollinated flower is correct? In this case, before we move, it's very important to note that for a wind-pollinated flower, anthers are found in the outside of a flower to release pollen grains easily into the air, and also the stigmas are positioned in the outside and are feathery to catch airborne pollen effectively. So in this case, the first option that we have been given is that the anther is inside. This one is wrong. Where the anther is inside is wrong. The stigma is also inside. This inside is also wrong. And then the stigma description is smooth. The stigma description is feathery. So the first option is wrong. B, the anther is outside. This one is correct. The stigma is also outside. This one is correct. Then the stigma description is feathery. This one is also correct. This one describes a windy pollinated flower. C, the anther position is outside the flower. This one is correct. Stigma position is inside. This one is wrong. Then the stigma description is smooth. This one is also wrong. Then D, the anther position is inside. This one is wrong. The stigma position is outside. This one is correct. Then the stigma description is feathery. This one is correct. But in this case for D, the anther position is inside makes it wrong. So therefore the correct answer is B, where the anther position is outside the flower, stigma position is outside the flower, while the stigma description is feathery. So the correct answer in this case is B. Question 19. Iron nails are placed in 4 test tubes under different conditions and left for 2 weeks. In which test tube does the iron nails show least amount of rust? Remember, the chemical name of rust is hydrated iron 3 oxide. It means it's iron which has reacted with oxygen and water. Therefore, in this case, we have conditions which must be there for rusting to take place. The first one is iron itself, second one is oxygen, and then the third one is water, or what we call moisture. moisture is water in gaseous state. Now for rusting to take place, the three conditions must be there. If two are there, one is not there, then there's no rusting. If one is there, two are not there, then there's no rusting. For rusting to take place, the three of them must be present for rusting to take place. Now, apart from these conditions, we also have other factors which can make rusting to take place faster, in what we call the factors which accelerate rusting. This one is like salty conditions. 2, we have acidic conditions. And then 3, we have very high temperature. And this one now explain why cars rust faster in Mombasa than in Nairobi, because in Mombasa we have a salty environment, acidic environment, and very high temperature. So that's why rusting takes place faster in Mombasa than in Nairobi. But in this case, we are interested with the conditions necessary for rusting. So in this case, for the nail which will rust most and the one which will rust least, then we must look at these three conditions: presence of iron, presence of oxygen, presence of water or moisture. Now, the first case A, we have tap water and this test tube is open, so it means there is oxygen coming in. Then we have an iron nail. Then we have tap water. In this case, we have water. Therefore, in this case, we have the three conditions for rusting. So in this case, rusting will take place most. The second one, we have boiled water. So in this case, we have water. Then we have this test tube, it's open, so it means oxygen can come in. And then we have an iron nail. Then in this case, we have also all the three conditions for rusting. So here rusting will take place in a very good way. Then the third one, we have moist air. Moist in this case, it means we have moisture. Moisture is one of the conditions necessary for rusting. Then we have an iron nail, and then the test tube is open. It means oxygen can come in. Therefore, also here rusting would take place easily. Then now the third one, we have iron nail. So we have one condition for rusting. Then we have tap water. We have not tap water but boiled water. We have that boiled water. Now it's boiled, it means there's no oxygen in it. So in this case, no oxygen, because when water is boiled, oxygen will move out. Now in this case, there's oil. This oil is preventing external oxygen from coming in. Therefore, it means in this option D, we don't have one condition necessary for rusting, and that is oxygen, because oxygen was expelled when we boiled the water. Therefore, in this case, rusting will not take place, and if it takes place, then it will be least, because one of the conditions, that is oxygen, is not present. Therefore, the correct answer here, where rusting will take place least, is where we don't have oxygen, and that is D. Question 20. Which expression is the definition of density? Remember, density is defined as the mass of a substance per unit volume. Now we can use this definition to come up with a formula where we can write density is equals to mass, then per, it means a division, per unit volume. Then in this case, we can write in symbols as density. We write as rho is equals to mass, small m, divided by volume, capital V. So in this case, this is the definition of density in terms of a formula. Now in this case, let's look at the options given. A, weight divided by volume. This one is wrong, because weight is not the same as mass. Then B, we have volume divided by weight. This is wrong. C, we have volume divided by mass. This is wrong. Then D, we have mass divided by volume. This one is correct. So in this case, the correct answer is mass per unit volume. Question 21. The diagram shows an alimentary canal and its associated organs. So you can see it labeled P, where P is a liver. Then we have Q, where Q is a stomach. Then we have R, where R is a large intestine. Then we have S, where S is small intestine. Then the question is, which row shows the labels for the parts P, Q, R, and S? So we have already labeled them, but let's go to option A. A, P is a liver, this is correct. Q is a stomach, correct. R is a large intestine, this is correct. Then S is small intestine, this is also correct. So A matches the letters P, Q, R, and S. Option B, stomach for P, this is wrong. Q is a liver, wrong. R is a small intestine, wrong. S is a large intestine, wrong also. C, P is a liver, correct. Q is a stomach, correct. R is a pancreas, wrong. Then S is a large intestine, this is also wrong. Then D, P is a stomach, wrong. Q is a liver, wrong. R is a pancreas, wrong. And then S is small intestine, this is correct. So the one which matches the letters P, Q, R, and S is A, where we have P as a liver, Q as a stomach, R as a large intestine, and then S as a small intestine. Question 22. The diagram shows a human female reproductive system, and you can see it here labeled P, Q, R, and S, where P, this is an ovary. Then we have Q, this is a fallopian tube. This is a fallopian tube. And then we have R, which is a uterus. Then we have S, which is a cervix. Now the question is, which row identifies the functions of the labeled parts? And the function that we have been given here is ovulation. Then we have fertilization, and then we have implantation. What we know is that ovulation takes place in the ovary. That is where ovulation takes place. And then fertilization takes place in the fallopian tube. This is where fertilization takes place. And then implantation takes place in the uterus. So in this case, we have what we call implantation. Now, in this case, we have to identify each of these parts and where these functions takes place. So for ovulation, it should take place at P. Then for fertilization, it should take place at Q. And then for implantation, it should take place at the part labeled R. So in this case, for A, that is P, correct. P again, wrong. Then S, wrong. Then for B, P, correct. Q, correct. R, correct. So the correct answer here is B. Then for C, Q, wrong. Then for fertilization, P, wrong. Then for implantation, S, wrong. Then for D, ovulation, Q, wrong. Then for fertilization, Q, wrong. And then for implantation, R, correct. So in this case, the correct answer here is P, where P, that is where ovulation takes place at the ovaries. Then Q, that is where fertilization takes place at the fallopian tube. And then implantation, R, that is where implantation takes place in the uterus. Question 23. Which item of apparatus is used to measure 25.0 cubic centimeter of aqueous sodium hydroxide in the lab? So in this case, we have been asked to find the apparatus that we can use to measure accurately and precisely 25.0 cubic centimeters of this solution. And what we know, we have apparatus which we can use to measure accurate volumes of chemicals or liquids or even solutions in the lab, and we have only 4. The first one is a pipette. The second one is a burette. The third one is a syringe, and then the fourth one is a volumetric flask. Now, what we are going to do is we are going to determine among these 4 apparatus that we have been given, which one appears in this list. But before that, let's name the apparatus that we have been given. The first one here is called a dropper. A dropper is also called a teat pipette. The second one here is a conical flask. This is a conical flask, graduated. Then we have C, we have a beaker, also graduated. Then we have D, we have a pipette. These are pipette. So you can see amongst the 4 apparatus that we've been given, one of it appears in the list of apparatus which can be used to measure accurate volumes in the lab. So in this case, the correct answer for an apparatus that can be used to measure exactly 25.0 cubic centimeters of aqueous sodium hydroxide is a pipette, and the correct answer is option D. Question 24. 4 beakers contains same liquid. I want you to underline this same liquid because it's very important in this case. At which point, so we have points A, B, C, and D at different heights in these beakers. At which point is the pressure greatest? Now what I want us to note is that pressure in liquids is affected by 3 factors. That is, pressure is equals to the height times density times the gravitational field strength. So the factors which affect pressure in liquids, one of it is height, second one is density, then third one is gravitational field strength. Now since we are on Earth's surface, this gravitational field strength G is constant. So it means that 4 beakers experience the same gravitational field strength. Then, and since this liquid is the same, that's why I told you to underline same liquid, then it means beaker 1, beaker 2, beaker 3, and beaker 4, they have the same density. Therefore, density in this case is also a constant. Then now, what is going to determine the greatest pressure or the least pressure is the height of the points in the beakers. So in this case, the one which is varying is height. Now let's look at the first height in the first beaker. This point X is at the surface of the beaker. Therefore, let's call it H1, which is almost 0. Then the second beaker, we have this point here, and we can call this one H2. This is H2. Then the third beaker, we have this one here, and we can call this one H3. And then the fourth beaker, we have this one here, and we can call this one H4. Now from this, which of these beakers contains the greatest height? We can arrange it from the highest to the smallest, where we have H3 as the largest height, followed by H2 as the height which is greater than H4 in this case, and then H1 is the least. Therefore, in this case, it means where we have H3, this beaker pressure will be high, our highest, followed by this one. This one will have pressure, high pressure also, but smaller than H3, that is C. Then this one will also have H4, will have a greater pressure than H1. Then this one will have least pressure because the height is very small. Therefore, in this case, we have been asked which point will have the greatest pressure. In this case, it is the point where we have the greatest height, and that is C. So the correct answer here is C, because height is large, density is constant, gravitational field strength is constant. Therefore, it means now in this case where we have the largest height, that is in C, that's where we'll have the greatest pressure. Question 25, the diagram shows the examples of wave motion. So in this case, we have the first one as a wave on water, where we have a rebel tank. Then 2, we have wave in air, where we have a drum being beaten. And then we have 3, where we have waves on a rope being kicked up and down. Then we have 4, where we have waves in a spring, where the spring is being kicked to and fro. Now the question is, which waves are longitudinal waves? Remember, longitudinal waves, these are waves in which the particle displacement is parallel to the direction in which the wave is moving. Like in this case, if you have a particle here and then you displace it in this direction, then the wave will also be moving in the same direction. So in this case, you displace the particle in this axis, then the wave will also be moving in the same axis. Then this is different from what we call transverse waves. Transverse waves is when you displace a particle, like in this case, if you have a particle here, you displace it up and down, then in this case the wave will be moving from left to the right. The particle will be displaced up and down, but the energy or the wave will be moving from left to right. This one is what we call a transverse wave. So in this case we have been asked which one is a longitudinal wave. Now the four waves that we have, let's classify them. In this case, for a Renewable tank, if you displace the water or if you drop a small stone inside the water in a Renewable tank, the displacement of particle will be up and down, but the wave will be moving outside. So in this case, this one is a transverse wave. Then the second one is a drum. You beat a drum across, and then you beat it like this, and then the wave will be moving in the same axis. This one is a longitudinal wave. Then we have three, kicking a rope up and down, but the wave will be moving in this direction. This one is a transverse wave. And then for a shrink spring, you kick the spring in the X direction, and then the wave will be moving in X direction in form of compressions. This is what we call a compression. And we have rarefactions. So in this case, this is also a longitudinal wave. This is a longitudinal wave. So in this case, examples of longitudinal wave from the above example is 2 and 4. Then transverse wave is 1 and 3. So in this case, option A, 1 only. No, this one is a transverse wave. 2, 3 and 4. This one is not correct because 3 is a transverse wave. 2 and 3 only. This one is incorrect because 3 is a transverse wave. 2 and 4 only. This one is correct because 2 beating a drum and also waves on a shrink spring kicked to and fro. These are examples of longitudinal waves where displacement of particles is parallel to the direction in which the wave is moving, and they move in terms of compressions and rarefactions. Compressions are regions of high pressure. This is high pressure, while rarefactions are regions of low pressure in a longitudinal wave. Question 26. Diagram X shows a leaf in which part Z was partially covered. Diagram Y shows the result after iodine added into the leaf. So in this case, you can see we have leaf X here and then leaf Y here. Then in this case, this part Z was covered by a black paper. Then after it was removed, then iodine solution was added to the leaf. This part Z that turned brownish yellow in color, and then the rest of the part which was not covered turned blue black. Now the question is, why is the area Z not blue black in color? In this case, what you need to know, when you cover this leaf part Z with a black paper, it prevented sunlight from touching that area. And remember, sunlight is one of the conditions that must be there for photosynthesis to take place. So it means if you covered it with a black paper, there was no sunlight, and therefore photosynthesis did not take place at that part Z, and therefore starch did not form. Now when you add this, or when you place this leaf in iodine solution, the part which was open where sunlight had interacted with turned blue-black because photosynthesis took place and starch was formed. But the part which was covered, it means no sunlight came there, therefore no starch was formed at that area. And that's how we test the presence of starch in the lab. Now in this case, the question is, why is the area Z not blue-black? The area Z is not blue-black because there is absence of starch. That is, A is correct. That part is not blue-black because there is absence of starch. Because if there was a starch, it could have turned blue-black. So the correct answer in this case is absence of starch. Question 27. A student has a bar magnet and 2 metal blocks. The student placed the bar magnet next to NW and NX of metal block 1. The student then placed the bar magnet next to NY and NZ of metal block 2. The diagram shows which end of the metal block are attracted or repelled by the bar magnet. So in this case, we have these two sides. This is where we have magnet, and then the other side we have metal blocks. But before we proceed, I want you to note something. For you to detect the presence of a magnet, we use what we call repulsion. We use repulsion to determine the polarity of a magnet. So this is the sure way to determine the pole of a magnet. Now, attraction is not a sure way. Attraction is not a sure way because when a substance is being attracted, it can either be a pole of a magnet, in this case opposite pole, or it can be a magnetic material, because remember, a magnet attracts magnetic material. So in attraction, it is a guesswork. It's either it's an opposite pole of a magnet or it's a magnetic material being attracted. Now in this case, for us to know if a material is a magnet, then we will see a place where there is a repulsion. That is the surest way to determine whether a material is a magnet, because like poles will repel according to the law of magnetism, and unlike poles will attract. So in this case, let's look at the first one, or let's look at the question: which metal block are bar magnets? Which metal blocks are bar magnets? So in this case, we have to look at the first case. In this case, we have a magnet with a south pole, and in this case, it's attracting the part W. Then in this case, this metal block 1, it's either a magnet or it's either a magnetic material. We cannot tell because it's an attraction. Then the second one, when you introduce the opposite part of this part W, that is part X, again attraction takes place. Remember, if this one was a magnet, this part W was being attracted, meaning it's unlike pole. But now for part X, if you introduce part X to the same pole, that is south pole, if this was a magnet, it could have been repelled, because if this one was an opposite pole, this one will be the like pole, which will cause a repulsion. So in this case, this metal block X and W, this one is a magnetic material. Then let's go to the next set where we have south pole. If you bring part Y, it get attracted. Now when you reverse this part Y and you bring Z, it get repelled. So it means this Y is opposite pole of south pole, so it means this is north pole. Now this is south pole. Now if you introduce south pole close to the south pole of another magnet, like in this case, there is a repulsion. So in this case, the metal block which is a magnet is metal block 2. So in this case, both metal block 1 and 2 are magnets? No, because in metal block 1, there is an attraction in both cases. You introduce W, there's an attraction. You introduce X, there's an attraction. So it means these are not poles. This one is a magnetic material. But now, when you come to metal block 2, in this case, you introduce Y, it gets attracted. But when you introduce Z, it gets repelled. And we have said repulsion is the surest way to note that a material is a magnet. So in this case, the correct answer is C. Metal block 2 is the one which is a bar magnet. Question 28. The diagram below illustrates a method of separating mixtures. Which letter labels a residue? So in this case, we are required to identify the letters A, B, C, and D, the one which labels a residue. But before that, let's first find out the method of separation that we have here. This is what we call a filtration. This is a filtration method. And this filtration method is used to separate a mixture, which is a solid liquid mixture in which the solid cannot dissolve in the mixture. Therefore, when you separate it, you have to remain with a residue, and then the filtrate will pass through the filter paper. So we have apparatus which we use to separate this one. Like in this case, we have a beaker. This is a beaker. And then we have this filter funnel. And then inside this filter funnel, we have what we call a filter paper. Now in this case, the part labeled A, this is the solid which remains inside the filter paper, and this is what we call a residue. And then we have this apparatus which we call a filter funnel. This is a filter funnel. Now the liquid which drops here is what we call a filtrate. is a filtrate, and then we have the liquid which has arrived inside the beaker is still a filtrate. So therefore the letter which represents a residue is letter A, and that is a solid which remains after a filtrate has moved through the filter paper. Question 29, which of the following is not a transducer? Remember, a transducer is a device. A transducer is a device that is used to transform one form of energy to another. So when we talk about a transducer, we're talking of a device which you can use to convert or to transform one form of energy to another. A good example of a common transducer is a bulb. A bulb is used to transform electrical energy to light energy, so that a bulb is a transducer. Now in this case, we have 4 of the the list that we have been given. Now in this case, we have to identify the one which is not a transducer. A, we have a battery. B, we have a speaker. C, we have a microphone. And then D, we have a dynamo. So in this case, for our D, which is a dynamo, this is a transducer because it transforms kinetic energy to electrical energy. So this one is a transducer. C, a microphone. This one is a transducer which transforms sound energy to electrical energy. So this one transforms sound to electrical energy. Then we have a loudspeaker which transforms electrical energy back to sound energy. But now A, which is a battery, although it converts chemical energy to electrical energy, it's considered more of a source of energy. Therefore, in this case, the one which is not a transducer is a battery, which is A in this case. A dynamo, in this case, we have said it converts kinetic energy to electrical energy. So remember, a transducer is only a device which is used to transform one form of energy to another. Question 30. 4 statements about atoms are listed. 1. The center of an atom is positively charged. 2. Protons and electrons are located in the nucleus. 3. Protons and electrons have the same mass. 4. Most of the mass of an atom is in the nucleus. Then now the question is, which statement are correct? Now for us to know the statement which are correct, let's draw an atom here. Then we have the energy levels like that. Now in this case, protons which are positively charged, they are in the nucleus. Neutrons are also in the nucleus. Then we have electrons which are found in the energy levels. These are the energy levels. So we have the nucleus inside, and then we have the energy levels outside. Then in this case, let's go to the first statement. The center of an atom is positively charged. That is true because in the nucleus we have protons which are positively charged and neutrons which does not have a charge. This one is correct. So this one is also, the first statement is correct. Then 2, protons and electrons are located in the nucleus. This is wrong because protons are in the nucleus, correct, but electrons are found in the energy level. So this one is wrong. 3, protons and electrons have the same mass. This one is also wrong because a proton has a mass of 1 atomic mass unit. A neutron has a relative mass of 1 atomic mass unit, but an electron has a mass of 1/1840 atomic mass unit. So this one is the same as 0.0000001. So in this case, when you say protons and electrons have the same mass, this one is wrong. It's not true. Then 4, most of the mass of an atom is in the nucleus. That is true because we have said protons have a relative mass of 1 atomic mass unit, and also neutrons have a relative mass of 1 atomic mass unit. So much of the mass of this atom is in the nucleus. This one is correct. Therefore, in this case, the statement which are correct, 1 and 2, this is wrong. 1 and 4, this is correct, that the center of the atom is positively charged and most of the mass of an atom is in the nucleus. This one is correct. B, that's the correct answer. Then C, 2 and 3, 2 is wrong, 3 is also wrong. Then the D, we have 3 and 4, 3 is wrong, 4 is correct. So in this case, the one which is completely correct is B, where we have the center of an atom is positively charged and also most of the mass of an atom is in the nucleus. Now let's move to section B, question 31. The diagram below shows a cell. So in this case, you can see this cell labeled X, Y, and Z. Then the first question A, name the kind of cells shown. So based on this diagram, this is an animal. This is an animal cell. Now on the same question, give 2 reasons for your answer in A above, and your answer should be based on the diagram. Now based on this diagram, this is an animal cell because 1 is that there is absence of a cell wall. What you can see on the screen, this is what we call a cell membrane. So in this case, we don't have the outer rigid layer, which is a cell wall. Therefore, the absence of a cell wall signifies that this one is an animal cell. Another reason why this is an animal cell is because of the presence of small vacuole. Remember, animal cells have a very large central vacuole, but for this one, which is an animal cell, it has a very small vacuoles which are scattered throughout the cytoplasm. Then question B, name the part labeled X. This part labeled X here, this is what we call the nucleus. Question 32, the diagram below shows 2 blocks, X and Y. Both blocks have the same dimensions. Height is 50 centimeter, length is 100 centimeter, and width is 20 centimeter. So in this case, you can see we have block X and block Y, where block X, that is block X in this case, has a mass of 2000 grams. If you convert to SI unit, it's going to be 2 kilogram, that is in SI unit. Then block Y has a mass of 4000 kilogram and it's in SI unit. Then the first question A, give the difference in mass between block X and block Y. So in this case, what we do, we take block Y, we subtract mass of block X, which is going to be in this case 4000 kilogram minus 2 kilogram. Then in this case, what we're going to get is 3998 kilogram. That is the difference in mass between block X and block Y. Then question B, calculate the density of Y in SI unit. In this case, density, we know density is equals to mass of a substance divided by its volume. So in this case, we have the mass of Y, that is mass is equals to 4000 kilogram. Then now we are going to look for volume. Volume is what we can find in this case, and volume of this block, we can get it by length times width times height, which is in this case, we are going to take the length, which is 100 centimeter, multiplied by 50, that the width, of course, that is 20 centimeter. Then in this case, what we're going to get, 100 times 50 times 20, this is the same as 100,000 cubic centimeter. But now if we convert this one into SI unit, that is cubic meter, then this volume is going to be 100,000 cubic centimeter divided by 1 million, then cubic centimeter times 1 meter cubed. Then in this case, our volume is going to be 0.1 cubic meter. Then now our density, which you can write as rho, is equals to mass, which is 4000 kilogram. Then we divide by 0.1 cubic meter. Then now our density is going to be 40,000 kilogram per cubic meter. So that is the correct answer of the density of block Y in SI unit. Question 33. The diagram below shows a food web in a field. So in this case, you can see a food web in a field. And in this case, we can categorize these different trophic levels. Here, we have what we call producers as a grass. Then in the mouse, rabbit, and the grasshopper, we have what we call primary. These are primary consumers. Then where we have a snake and a lizard, this is what we call a secondary. These are secondary consumer. And then where we have an auk or an eagle, this is where we have a tertiary consumer. Then now the first question in this case is, name a secondary consumer in this food web. Now for you to name secondary consumers, I've already categorized them. We have a snake and we also have a lizard. So the secondary consumer in this case is either a snake or a lizard, and this is because they consume primary consumers. In this case, they consume things like a mouse, a rabbit, and also a grasshopper. So those animals in a trophic level which consume primary consumers, we call them secondary consumers. Then question B, explain why it's difficult to classify an eagle, or in this case a hawk, as a secondary consumer. The reason why it's very hard for us to categorize this hawk as a secondary consumer is because it consumes both primary consumers and also it consumes secondary consumers. Like in this case, if you follow this route at the middle, we have grass, then we move to the rabbit, and then this rabbit is being consumed by the hawk or the eagle. So in this case, the eagle acts as a secondary consumer. But if we follow the other route, grass, we go to the mouse, then we go to the snake, then we go to the hawk. At this level, the hawk or the eagle behaves like a tertiary consumer. Now, the reason why we cannot categorize this eagle as a secondary consumer because it feeds on a varied diet, and that means that it occupies multiple trophic levels, making it difficult to classify strictly as secondary consumer because it also behaves as a tertiary consumer. Then tertiary consumer, we can construct two. The first one, we will begin with the grass, then we go to the grasshopper, then we move to the lizard, and then finally a hawk. Or you can also use this route. We have grass, then you move to the mouse, then you move to the snake, and then finally you move to the hawk. Mwaka has a mixture of glass beads, salt, sand, and steel border. The glass beads are much bigger than the particles of sand and steel. Study the flowchart describing how she separated the mixture. So in this case, we have a flowchart where we have the mixture of glass beads, salt, sand, and steel border. But remember, in this case, we have been told the glass beads are much bigger than the particles of the rest of the mixture. So in stage A, she separated the glass beads and then she remained with a mixture of salt, sand, and steel border. And then in stage B, she separated what we call the steel border, and then she remained with a mixture of salt and sand. And then now stage C, she separated sand and she remained with salt solution. So in this case, for you to separate a mixture of glass beads, salt, sand, and steel border, where glass beads are larger than the rest of the particles, in this case, stage A, you will use a sieving. So she used sieving so that she obtained glass beads because they are large particles, and then these other particles were sieved. Now in stage B, where we have a mixture of salt, sand, and steel border, for you to separate steel border, because steel border is magnetic, then in this case, stage B, you will use a magnet. You will use a magnet as a method of separation, because now steel will be attracted to a magnet, steel border will be separated. Now you will remain with a mixture of salt and sand, and then now in this case for salt and sand, then you will dissolve this in water, and then you do what we call filtration. Because sand cannot dissolve in water, but salt solution or salt will dissolve in water. In this case, you will dissolve in water and then you do what we call filtration. So in this case, for A, the question is asking, name the process used in stage A, B, and C. So in A, you did what we call sieving to sieve out glass beads and also obtain salt, sand, and steel powder. In stage B, used magnetic separation, where steel powder will be attracted by a magnet, leaving behind salt and sand. Then stage C, in this case, you do what we call filtration. You put water in the mixture, salt will dissolve, sand will not dissolve, and then now you do what we call filtration. So that's how Mwaka separated the mixture of glass beads, salt, sand, and steel powder. Question 35. ISA has two carts. The carts have the same weight, but one has 4 narrow wheels while the other has 4 wide wheels. So in this case, we have the cart with a narrow wheel, while in this other side, we have a cart with a wide wheel. So in this case, the question is, which cart will sink less into the soft ground, and what is the reason? So in this case, we are required to find out the cart which will sink less into the ground, therefore it means which will exert less pressure. So before we go into the answer, it's very important for us to remember that pressure in solid is equals to force acting perpendicularly per unit area. And now, since we have been told the weight, remember weight is a force, is the same for the two wheels, therefore F is constant. Therefore, it means now the only variable which will determine the amount of pressure exerted will be the area. And in this case, it means if you increase the area of the wheel, then pressure is going to be lowered. And if you decrease the area, then pressure is going to be increased. So in this case, the wheel which has a large area, it means pressure is going to be low. So in this case, a wheel with a wide area, pressure is going to be low. Then on the wheel with less or a narrow wheel, in this case pressure is going to be very high. And I want us to investigate this in a very short way. So in this case, assume you have a force of 20 Newton, which we have said is a constant. Then in this case, the wheel with a narrow area, let's say it has an area of 10 meters square, and then the wheel with a wide area, let's say it has an area of 20 meters square. Then in this case, what we do for us to find pressure on the larger wheel, then what we will do here in this case, we will say pressure is equals to force, which is 20 Newton, divided by area, which is 20 cubic square meter. Then in this case, we want to find our pressure as 1 Newton per square meter. Then now the pressure for the smaller or the wheel with a narrow wheel, in this case it's going to be pressure is equals to force over area. Since weight is the same, 20 Newton divided by 10 square meter, then in this case our pressure is going to be 2. Our pressure here is going to be 2 Newton per square meter. So you can see when we have a small area that is 10, pressure is 2. But when we have a large area that is 20, pressure is 1. So a large area signifies less pressure, and then a small area signifies a large pressure. Therefore, the wheel which will sink less into the ground is the wheel with a small pressure, that is a wheel with a large area. So in this case, we can explain this by saying the cart which with a wide wheels will sink less into the soft ground, and this is because wide wheels distribute the weight of the cart over a large surface area, reducing the pressure on the ground. And when lower pressure is exerted on the ground, this means that the wheel are less likely to sink into the surface. Question 35b. Diagrams X, Y, and Z represent 3 states of matter. So in this case, you can see we have states of matter labeled X, we have another one labeled Y, and then another one labeled Z. The X one, this is in gaseous state. Then the Y one, because the particles are randomly packed and they are close or closer to each other than X, in this case this is a liquid. And then in Z, particles are regularly arranged and they are close to each other. This one is in solid state. Then the first question is, which letter will represent a change when iodine solid turns into iodine gas? Remember, iodine is an example of a substance which undergoes sublimation. Therefore, when it changes from solid to gas, in that case we call it sublimation. So therefore, in this case, the changes or the letters which represent a change when iodine turns from solid to gas is letters Z to X. Z moving to X. That is when iodine changes from solid to gas. And this because in Z, it shows particles which are tightly packed in an orderly arrangement, that is in solid. Then diagram X shows particles are spaced far apart, that is in gas. Now the process where iodine changes from solid to gas directly sublimation, and iodine undergoes that process. Then the second question, explain why particles in diagram X can move freely in X, this in gases, why they can move freely, while those in Z, that is in solid, cannot. So in this case, in diagram X, that is in gaseous state, particles are far apart from each other and they have what we call weak intermolecular forces, and this one allows them to move freely because they possess what we call high kinetic energy. While in diagram Z, that is in solid state, particles are closely packed in a fixed position, arranged in an orderly manner, and in this case they have what we call a very strong intermolecular forces, and they possess a very small amount of kinetic energy. That's why they only vibrate within their fixed positions and they cannot move freely within the space that they occupy. Question 36, study the diagram below and answer the questions that follow. So in this case, you can see the diagram that we have on the screen. Then the first question is, define the term energy and explain or understate its SI unit. So in this case, the term energy is defined as the ability to do work. The SI unit for energy, SI unit, is joule, which is given a simple capital J. Then question B, identify the main energy transformation that takes place when the gas cooker is being used. When you are using the gas cooker, remember we have a gas inside, which is a chemical. So in this case, we begin by chemical energy, then getting transformed to heat energy. Getting transformed to heat energy. So the energy transformation in this case is chemical to heat energy. And then C, what does the symbol on the gas cylinder represent? The symbol on this gas cylinder here represent what we call a flammable. This is a flammable. It represents substances which catches fire easily. Question 37, define the term focal point for a convex mirror. So we define the term focal point for a convex mirror as a point from which the reflected ray appear to diverge. And in this case, if we have a convex mirror here, this is our convex mirror, and in this convex mirror we have what we call the principal axis, like this here. Now on this principal axis we have the focal point behind and also the center of curvature, like that. So in this case, if we have a paraxial ray, a ray which is parallel and close to the principal axis, like we can draw it here like that, this ray will appear. Remember, this ray we call it incident. This is an incident ray. Now after reflection, it will appear as if it was diverging from a point behind the mirror, and that's the point which we call the focal point. So after reflection, this ray will appear as if it was coming from this point here behind the mirror. So this is what we call a reflected ray. So in this case, that's why we define this focal point. Let me label it. This is the focal point. That's why we define the focal point as a point from which this reflected ray will appear to diverge from after reflection from a convex mirror. Question B, use a ray diagram to locate the image of the object below placed in front of a concave mirror. So in this case, we are going to we have a concave mirror here on the screen, and we are going to use any of the 4 rays that we discussed. So in this case, if you have never watched a video which describes the 4 rays, then I will urge you to look at the comment section. I will pin the link there for the video so that you also benefit from this. So the first ray that you're going to use in this case is a ray from the tip of the object parallel to the principal axis, like that. This ray will get reflected and it will pass through the focal point, like that. So in this case, it will pass through the focal point, like that. That is the first ray. Then the second ray that we're going to use here, we can use a ray from the tip of the object through the focal point, like this. In this case, let me use a red pen. So in this case, we are going to have another ray from the tip of the object passing through the focal point to the mirror, like that. After reflection, this ray will be reflected parallel to the principal axis. This one will be reflected parallel to the principal axis, like that. Now, where these 2 rays meet, that's where the image will be formed, and where they meet, that is where the tip of the object is going, or the image is going to be. So now this one is our image. So in this case, that is how you can locate the position of the image from the object placed in front of the mirror. Remember, this one was our object. So in this case, you have used 2 rays. This ray, this is the first ray, then this red one is the second ray. If you have not watched a video where we discussed these 2 types of rays and how you can use them, kindly visit the comment section. I'm going to pin a link for the video on the same so that you also benefit from this important information. Question 38. Study the diagram of a leaf tissue below and answer the questions that follows. So in this case, on the screen, we have the part of an internal part of a leaf labeled A, B, C, and D. And then the first question, name the structure labeled A, B, and C. The part labeled A is what we call the epidermis. Then the part labeled B is what we call the palisade mesophyll. And then the part labeled C is what we call the spongy mesophyll. Then question B, explain how the structure labeled B is adapted to its functions. This part labeled B, which we have said is a palisade mesophyll. In this case, we can say the palisade mesophyll cells are elongated and tightly packed with a high number of chloroplasts, which maximize light absorption for photosynthesis. So as you can see, this spongy mesophyll, these parts are tightly fixed together and they are close to the epidermis. Now this is because they have large amount of chlorophyll, which is used to trap light, which can be used in photosynthesis. So the reason why they are closely packed is to maximize light absorption for photosynthesis process. And now their position is just below the upper epidermis to ensure that they receive maximum sunlight. Their positioning is just close to the upper epidermis, and this one is because they will be close to the sunlight. Question 39. The diagram shows 4 identical pieces of potato plant tissue in a test tubes. The pieces of potato were kept in the test tubes for 6 hours. So in this case, you can see we have A, where we have a potato plant or a potato plant tissue with distilled water. The second one, B, we have a potato plant with 5% of sugar solution, and then C, we have 20% of sugar solution, and then with a potato plant, and then D, we have air with a potato plant. Then in this case, the first question, A, what biological process is being investigated? The biological process being investigated is what we call osmosis, and osmosis is defined as the movement of water molecules from a region of higher